Hi, this is Jeff Blair of ISA St. Louis section. I'll take a few minutes to explain pressure transmitter accuracy today. Here's a look at our agenda. We'll talk about how to select the transmitter, how transmitter accuracy is calculated, and we'll look at some sample applications looking at hydrostatic level. My goal by the end of this presentation is to show you practical applications of how transmitter accuracy may impact your measurement. Just to be very upfront, there's a lot of subtopics that go into pressure transmitter accuracy, such as accuracy when diaphragm seals and capillaries are attached, as well as accuracy when a transmitter is connected to a primary flow element. I will not be covering those. Rather, my goal is to point out some of the accuracy statements and calculations that the average consumer of transmitters may not be aware of. I want you to know how to evaluate and calculate accuracy given the proper tools. What I've done in my professional career mostly is work in process automation. My opinion is that if you're into instrumentation or automation, ISA is the place to be. Personally, I'm grateful to ISA for the networking and learning it's allowed me to do over the years. I came out of the 1st Infantry Division in 1998 and went straight into the electrical industry and moved into automation in the mid-2000s. I love analogies. I think one of the comparisons you can make to selecting a transmitter is selecting a speedometer. If I told you that your job is going to be to work for one of the big 3 auto manufacturers and you were going to crash test their cars at very low speeds to test bumper impact, it's very critical you crash the car at 5 miles per hour. Now, which speedometer would you choose and why? The same thing can go into selecting a pressure gauge. If you were measuring a normal operating range of, say, 5 psi, which one of these gauges would you buy? How about if I told you that 100 psi was your normal operating range? I want to cover some important terms. Range and span are very important to almost any process instrumentation application. Think of the range as 2 numbers. It's the lower range value and upper range value of your application, also 4 to 20 milliamp or 0% to 100%. Think of the span as 1 number. It's simply the difference between the two. In just a few minutes, I'll show you how to calculate a 4 to 20 milliamp span for a typical pressure application. And here's why range and span are relevant to selecting a transmitter. Manufacturers give you choices, just like the speedometer and pressure gauge at the beginning. You choose a span code or a range code. Manufacturers may call it different things. Like you see in my example here, each span code has span limits and range limits that must correspond to your application. Ensure you select the proper transmitter for your application. When you get into the next step of looking at transmitter accuracy statements, you'll encounter a wide array. I think all of these are good accuracy statements, except maybe the one at the bottom because it doesn't quantify. Issues arise when we try and use accuracy statements without any units of measurement. Generally speaking, manufacturers' standard accuracy statements refer to reference accuracy. Reference accuracy accounts for 3 things: linearity, hysteresis, and repeatability. But different manufacturers have different meanings of accuracy, so we need to find a common way to measure it. When looking at accuracy statements, there are a few things to keep in the back of your mind. For example, how accurate of a transmitter do you really need? Differential pressure transmitters rarely stand alone. They are connected normally to some type of piping. Piping may leak. They may be connected to a diaphragm seal or capillaries that have temperature fluctuations and physical changes over time. Same thing with orifice plates. But back to range. Where is your transmitter expected to work? Is it a stable, consistent process, or it is a tank you may run a batch process in? You're going to fill it empty so it will continuously see 4 milliamp to 20 milliamp ranges consistently. So we looked at accuracy statements, but let's dig a little deeper. There's a common way to ensure the playing field is level, and you can compare. It's called Total Probable Error, or TPE for short. TPE accounts for the things that you see here. Now we know that TPE includes reference accuracy, static pressure swing, and ambient temperature swing, we can calculate with a manufacturer's calculator or use the root mean square method you see here. I'll walk you through a brief application of TPE looking at a standard pressure transmitter used in a hydrostatic level application. Let me show you the application. Level is equal to the height of the liquid times the specific gravity. So here we have our minimum level, 20 inches, times 0.8 equals 16 inches. Same format, a little bit different dimensions for the maximum level gives us 176 inches. Our range, which is always two numbers, and here it's going to be 16 inches to 176 inches of water, and our span, which is always one number, is going to be 160 inches. Keep that in mind. We'll come back to it after we look at what goes into total probable error. Here we look at the total probable error taking into account sensor accuracy, static pressure, and ambient temperature effect to get 1% of overall span accuracy. Using that 1% of span example against our 160 inches span means that we have an error of plus or minus 1.6 inches of water. So if your transmitter or milliamp equivalent says 176 inches of water, we actually have between 174 and 177, almost 178 inches of water. At the low level, 16 inches actually means 14.4 or 17.6 inches. That's plus or minus 10%. May or may not be a problem for your process, but it is plus or minus 10% at that low range in this application. So you may be thinking to yourself, 10% inaccurate, really? You have to look at the application. What can your process tolerate? If my home weather system is off by a degree or two, it really doesn't matter. But if 1 or 2 inches of liquid level means I may burn out a tank pump, that's an issue. The way pressure transmitter worked, and that may be another video based on your feedback, the inaccuracies are going to be at the low end of the range if that's any relief. Also, to help your accuracies, go back and look at the range and span example and make sure you are picking the smallest span code size for your application. Have your instruments factory calibrated. Manufacturers almost always have the most accurate calibration equipment at the factory. So finally, thank you. And moving forward, I ask that you consider looking at total probable error to measure transmitter accuracy, and take that and apply TPE to your applications so you know your accuracy at low, mid, and high ranges. Always consider alternate technologies. This presentation was based on pressure transmitters. I used the hydrostatic level example, but we all know you could use potentially radar, buoyancy transmitters, ultrasonic level transmitters, point level switches. There's so many different technologies for each application. Finally, I ask, please look me up, connect with me. Here's my LinkedIn information. I appreciate your feedback. If you'd like to contribute your thoughts on this presentation and how accuracy may or may not be important to you, please do. Here's my survey link. And also, you may test your newfound or refreshed skills at the link here for a brief quiz. I really look forward to talking to you. Thank you so much for your time and attention.